Welcome back to another video. So in this video I'm going to show you a little project I've been working on for a while. So if you have followed me on Twitter, you will see that I've tried to put the tape signals out on a LED bar here, bar of LEDs or array. And kind of works. So what you do is you adjust and you see that the LEDs stabilize. So we'll get into that later in the video. And there's a lot of guys that are much more knowledgeable than me. So this video has been sponsored by PCBWay. So I will just show you the board now. Really happy to get this, and it will be fun to see if we can get something out here. So basically what it's going to be is like this one goes into the C64, and then you will plug the tape drive in there. So these ports are 1-to-1. We will have a microcontroller, the Arduino Nano. We have 6 LED bars with 10 LEDs each. So that will be 60. So the way this is going to work is that when there comes a pulse, if it's a short length pulse, the LED will light up down here, I think, or maybe up here. If it's a medium, it will light up in here somewhere. And there's like hundreds of the protocols, so I figure out, okay, let's not go into protocols. Let's just display the damn signal. And if I have to group something, like we could think, okay, we only have like this amount of LEDs. I have to figure out, okay, let's just look at the short ones. Then we have to cut out all the long ones. Alright, so I'm just gonna solder this up with LEDs and everything. So we are going to have a couple of resistors. Oh yeah, let's talk a little bit about the board design. So here you have the ports. They are in here and out here. So you plug the tape there and this one into the C64. And you can see it's 1-to-1. And then we tap off cassette read, goes into the microcontroller Arduino Nano. We have 8 LEDs which are multiplexed by 6 bars. And here you have the bars. So it's very simple. And also just want to say right away, you can't really drive all of this at the same time and then use one resistor. But I'm just going to drive one at a time and use persistence or vision to show you what's happening on the tape signals. Right, so it's the 27th of December and I have some free time and I'm playing with the Arduino here, Arduino Nano, and I'm having a signal in on D8, which is coming from this signal generator or digital discovery set to output a pattern, basically just a 1 kHz clock signal. And these LEDs are ready for use later, so this is going to show jitter or something like that from a tape. Right, so I'm just going to load up Arduino and the waveform which is controlling this digital discovery. Right, so the program is ready and we have a output diagram or a serial monitor here, and we can go into waveforms here and select patterns and add 27, and then on 27 we're going to do a clock at 1 kHz and run, and then the microcontroller outputs this. So you can see the frequency is measured, and it measures also high time and low time. Now before looking at the code, which is a bit boring, I will show you some diagrams instead. Maybe this is as complex as that code, but this is the clock function for the timer 1, and there's a timer counter, and then you have like OCR, which is like detects whenever the timer is of value. But what we are interested in here is something called ICRN. So what happens is that it copies the value in there when you have like an edge. It's called input capture, and this diagram is much simpler and shows it much better. So the counter is just a 16-bit value incrementing all the time. So what happens is that this one is incrementing all the time, this one, and then whenever you have something in on, we saw D8 here, you can select either the rising or falling edge. So let's say we do the rising edge, and it will be detected, and you get a write signal. So what happens when you get a write signal? It takes the counter and puts it into another register. So it kind of saves it in real time. And real time is very important here. So if you can save in real time, you're not so dependent on your CPU wherever it is in its execution. So what you have to do now is to pick up an interrupt and then take that value and put it in the memory. So the first thing we do in the program is, this is from copied from the forum of Arduino, and basically it sets up which flag it's going to trigger on, and it has starting the timer, and it also selects which pin or input capture edge select, which is 1 or 0. So in this case it's 1, so that's rising, and then enable the input capture and then the overflow. So the overflow is when the timer goes around. If it goes beyond 65535 and it goes to 0 again, you get an overflow. So you can detect that also and just add it to your calculations. So you will need a program that displays time, and then you will also need an interrupt service routine. So I'm not going to go so deep in that, but basically what happens is wherever you get those interrupts that I was talking about, you will see if it's an overflow, it will just increment overflow. If it's a rising edge, it will do this, and whatever it's doing is taking that counter value and together with the overflow and then storing it. So here you get the results, but at the bottom you can request another sample. So the way you do that is basically just set that variable to 0, and you have to control the interrupts also. So I was surprised how well these values are calculated. I'm printing out the raw measurement, and this is printed about a second or every 500 milliseconds or something. Anyway, so let's change the frequency. Let's say 5 microseconds or 5 kilohertz. Yeah, it picks it up. We can try 50. I know that works. Yeah, that works. Yeah, so now we're only 321/16 of a microsecond. So this is from C64wiki.com, and this is the Commodore format. So there you have 3 different sizes you can pick up, and that's basically it, what we are going to do. Right, so I'm panning out some IOs here, and I think it's a good thing to start and see if you can see all the transitions. Right, so this is already a lot better. You can see it looks like it's skipping one. Okay, I got something working here. So I figure also out I can actually change this. So when I press enter now, look, it moved. So that means the difference is 8 from 1000. I'm displaying a value between 0 and 15. And right now it's just a difference between 1 kilohertz and this value plus 16. So therefore I get 8, which is in the middle. So now I can go to say 2. So as I press enter now, let's try 3, see what it does. So just pulled out my 250/407 C64 revision, and this is the cassette read. So I have traced it from this connector down to the SID chip, so it's connected there. You can see this blue clip-on thing, and then this ground up there. And I have extended the lines. This is a bit more practical, and you can see, and you can see it comes in, yeah, kinda, you can see it's in on D8 there. Alright, so this is the 4th take. I'll have to rewind the tape again. So, we have loaded Graham Axton's The Bare Essentials. I really love that game. And Vanya has made the graphics. Now I have the computer on. I will just reset it. And then we will take run about now. Check that it's revolving, and I'm just gonna hit clear. Yeah, so this is Sven Pettersen's website, and I was noticing it was guitarsite.de, and I was seeing that it was Sven, so that was cool. So I will talk about that just in a moment. 173, and now we're seeing a bit longer pulses and a bit of mix. So if I see a long one now, I saw a long one, so I will stop the tape because then the scrolling stops as well. So yeah, so I found this page. I was looking for the synchronization header at the beginning. So you have a 10 seconds of 2.8 kilohertz. That's actually in NTC mode, but we are running in PAL, and I figured out that this was actually a short series of short pulses. In PAL that would be 1.82 microseconds. So yeah, so let's have a look at the printout. So thank you very much, Sven. So really happy that you made this website. There we go, 320 again. Yeah, so this tape is probably running a bit fast. But yeah, so this is a short pulse. Oh, sorry, a long pulse. And I think that will be the marker for the end of the byte or something like that. I seem to remember what they are called, but I think it's called VU meter LEDs or something like that. It has 10 LEDs in them, and you can stack them. So, right, so this is like the 5th time I'm recording this. Yes, so I have a new program. So what I'm displaying here now is actually percentage error, which is like plus and minus 8% or something like that, and 0 in the middle. Alright, so there we go. And we see it's not dancing all over the place, it's staying between like 3 LED or 4 LEDs there. So that's good. So I will screw about quarter turn to the left, or counterclockwise. And there you can see it jumps around all over the place. That's what I wanted to see. And now I will turn it back. Yeah, there it goes. So it's Commodore Run. Yeah. Anyway, I'll just pause the video until we see something. Anyway, we have some guard tone going on here. I call it guard tone anyway. Synchronization tone. That's the word. Yeah, there we go. Bear pond. The space. Let's see if it goes into the fast loader. Yeah, it's already doing something there. Already 121. We have some action going on here. The Bear Essentials. I love this game, by the way. And that's why I bought it. I also bought it for this drive. I believe I have it up there somewhere. Together with all the candy I got for Christmas. Let's see. There we go. Yeah, there we go. Bear Essentials on disc. See? Pretty cool, isn't it? It's been a long time since I've actually tested this disc. So that's pretty cool. I love this. So now let's make the PCB. Look what came from mail. PCB way. Let's see what we got. Oh yeah. this. That was actually pretty quick, just under a week. So there is a C64 tape pulse time visualizer. Look at that, C64 tape pulse time visualizer. So you're gonna have all these LED bars here, so there are 10 in each. So that's 60 LEDs actually on one Arduino. Yeah, it's pretty cool. So this didn't take long at all. 5 boards from PCBWay. They only had a couple of questions about the beveling of the edge connector. Yeah, you can see it's a bit beveled there. So it's 45 degrees. I was saying 20 or something, but they said these pins would be pulled back a little bit if I did that. So this is cool. They were very quick to reply, and I'm very glad I did. So perhaps next time I'll make them a little bit longer because of this beveling. So thank you very much, PCBWay.
Ja, de sier det, at det skal holde.
So before we start, we need to figure out which side is which. Oh, some of them are a bit bent. So there's nothing indicating here which side is which. There's just some markings here, but nothing else. So we need to find the cathode side. So my cathode side is on the top. All of these have the cathode on the top, so cathode means just the negative side, which goes to the resistor. So yeah, so we just use the multimeter. So the diode mode. There you go. There you go. Too many, so I'll put them back. Also, we will need some of these guys for the microcontroller. And I'm not going to use any sockets, I'm just gonna solder it down. So, yep, so it will go this way. It's a bit tired to have the camera in the lap, so I'm just gonna set it there. So, oh. So what I'm going to do, I'm just going to solder one pin at a time, and the reason for that is because when you solder more, you can't adjust it. If you solder one, you can adjust it and heat only the one pin. So yeah, I'm just going to tape that one down. In matter of fact, I think I will just do them all. Tricky because some of these pins, they bend. So, but yeah, this is good. And now let's just tape it together. And we're just gonna solder one pin at a time. Okay. So now I don't know where the other one starts, so I'm just gonna take one in the middle there. Okay. So we take the tape up because now it's holding. Sorry. Okay, so this one, now you can see what I mean. This is not great. And I wasn't expecting it to be this bad, but okay. So what we do then is you put your finger on it and then you heat the one pin that you soldered. There it solidifies, and you can turn it around, it looks good. So same for this one. Sometimes you can feel that it's clicking into place. You can do the same over again on the other edge, but this looks good already, so I think we'll just continue. Yes, I've been soldering up everything, and I figured that, oh my gosh, while I was mapping out all the outputs, I saw for programming, I saw that these are input only on LED 6 and 7. So I will use some other pins for those, and here, these are LED 6 and 7, and I will put them up here instead. Right, so I'm programming and trying to get a value out on the display, and I'm slowly getting there. You see, it doesn't move correctly. It stops. But yeah, I'll figure it out, and I'll talk about the code later. Oh. Right, that looks already a lot better. Alright, so I think I will keep such a sequence at the start so we can see that it's working properly. Right, I think I have something working here. So it's a bit weird, because now the input is not connected to anything, so it's dangling. So it depends what I hold it next to. So if I put it up to this light here, it seems to react at it. And if I move my feet on the floor, it's the next day, so I've hooked up the digital Discovery by Digiland, and it has outputs. I didn't know what these were, just inputs. Anyway, these are outputs, outputting a signal on D8, which is that special input for input capture. So I'm feeding in a few signals, and I want to get the scaling right. So if I switch to, say, 2 kilohertz, I'm going to click it. You can see it moves. You can do 5 kilohertz. It goes there. So I haven't got the scaling right now, so I will just hook up a tape and this one into the C64 and see what's happening. So let's try. Oh yeah, it goes in, but it should have gone a bit further. So that means I need to, like here, I need to protrude that bit. Yeah, so I will figure out later how much. That's okay for now. And also, if this was in a case, it would be even worse. So yeah, I haven't paid attention to that yet. That's okay. Let's hook it up, and then let's hook up the tape, and that's it. We have the tape drive in there. It's hooked up power. The LED isn't lighting anyway, but you can see it turns on. And press play on tape. I think it's Commodore run stop, not sure. And yeah, it's revolving. We see a signal here, don't we? I'm not sure. Yeah, there we go. This is what I want to see. So this is just the starting tone, or the long pulse, and here you can see, yeah, this is what I want to see. And now it's press space time and it continues. There you go. I wasn't sure this was what I was going to see. I was thinking of seeing three of them, but not 2. But it could be that it's now in a fast loader or something. So now this camera is in the height of a small child, so that will give you the best nostalgic feeling. So I've turned it off, and I will hook up the Arduino to my computer. There. And then, maybe it's not so easy to see what I do, but I will change the pulse height time here. Yeah, this is a problem I have. Sometimes I connect the wrong USB cable. Yeah, so this is a quarter turn out. And you can see those turns into 4. And that's also something we saw in this tape adjusting. Quarter turn back. And you can see they collect. And then the other way, same thing happens, just much worse. That's what I wanted to do with this thing. This looks rather nice. So let's try the azimuth head alignment tape. It even comes with a tool. And now it's on the floor. And we have cutouts so you can see where you turn the needle or the alright, so this is tape, and you have the Interceptor's micro software on this side. And then you have a game called Bandana City, which I like the tune on it. It's very simple, but it's very nice. So, alright, so this is like 3000 baud or something like that. So let's have it rewind, and let's. Seems like this one has reset or something. So. There you go. This looks like the tone you see at the first. So, and then it will display the file name. So that will be 3 pulses. There you go. And then it will load the fast loader program, and then I think it's already done. Well, I'm not sure. I don't think it has. No, it's doing it. So it has to load its own program first, and then it automatically starts, and then it will have 2 pulses only, and those are used for adjustment. So this is the pulse, and this looks a bit different. This is a reference tape anyway, so but if I push on the lid, it could be that it's not sitting correctly. But yeah, we're going to try. Oh yeah, now you can see it's very unadjusted, so let's go clockwise. And that's quarter turn. And now it's beginning to go off. Okay, so now I think I tighten the screw actually. Then I will untighten it until, there you go. Wow. So this looks good. I think I'll connect it to the screen now and see if it's actually loading. So. And the counter should start there. There it starts, and you can see you have those 2 pulses that I was adjusting to. And it does look like it's working. So how this works, you've probably seen this in many videos. And it means that this counter is going to 8000, then you have reached, then you adjusted it properly. And it stops like this. So heads are aligned, so that's cool. But yeah, so this works. So let's try Bandana City and see what that's like. Oh yeah, this is good. So the deal here is that it's going to load 140 blocks. So this is also a test actually. Tells you how many blocks there is, and if the game loads, it's okay. And this is also, as you can see, a custom loader. Usually there's no display on the screen. So this is probably a even fading out. That's nice. That was the last one. And this looks good. So now it's working. I think this is good enough to say it's working. So that was rather interesting. So we need a few adjustments to make this work perfectly. So we will have to take away some material on the side here. So this one will go further into the machine without hitting the board hitting the plastic here. So, and this one is okay. It's actually the same design as the C64 motherboard, so I'll just leave that in. Now if I put this one in a 3D printed case, maybe I will want to change here, but I don't think so. Other than that, there's also, I'll turn the machine off now, there's also these bodges that I will fix. So, two camera setup. We have a 2-camera setup now, and we will film the screen at the same time as I film this device while I run the SMED 3000. And I will load the recorder gesture program from my Kung Fu Flash. A recorder gesture is German for cassette azimuth, I think, or more like tape adjust. But anyway, here you have F1, and then you can like have help lines, and then you have F3, you have help lines for turbo tape and such. So let's try starting. First you're gonna rewind it to, I think it was 30 or skid. There you go. So this is my third take because I forgot that I actually had to start the tape before inserting the screw. But however, now we're going to look at the display and the screen at the same time. And there you can see there's a similarity. Right? There you go. It doesn't always show the slow process. I have to just look into that. This looks good. So what you're seeing is short, medium and long. And on the screen you can see from left to right, it's short, medium and long. So it's sort of the position of the screen here is the value from the timer in the C64, the CA chip timers. So yeah, so here we go. We have the turbo running. And if you press F3 you get a bit more zoomed in. Yeah, so let's try adjusting it a little bit. Try to see what I do. Quarter turn out. There you go, now we're starting to see weird things there. Yeah. Even more out. Now we see it's all over the place, and it's also all over the place here. And then turn to the right or clockwise. You can see they are gathering together. And now the screw is very tight. And there it seems to go worse again. So then you will back off a little bit until it gets worse. There, and then in the middle you will stop. So actually I have to do this with this arrow connected. But anyway, this is looking really good now. So yeah, I'm happy with this, and you can now see the similarities between this and on the screen. So. Alright, I'd like to try something else now, on the, not just those two tapes. But if you see up here, the box of tapes is actually underneath all of these. So I have to be a bit careful. There's a data set there actually. I have several data sets. It's been a while since I opened this, so let's have a look. Oh yeah, nice. Nice, lots of tapes. Look, turbo tape. Turbo tape. Another turbo tape. I don't know what this is. I think one of my early tapes are here as well. So it would be nice if we find something. Maxa, I don't remember. Yeah, these letters, I haven't put letters on mine, so it could be this one. Boulder Dash. No. But I remember those quality tapes. Those were the one that was working. Yeah, this is a bit of Norwegian history actually. It's called Kassettklubben. And it has a lot of programs on it, like Printing Lab. Yes, so here we have a turbo tape. It's from when I bought a machine 8 years ago by a guy not very far from here, and I think it was CLC. So this is probably his tapes from his childhood, and we have loads of game on it. Pit Stop 2, Pipeline, Super Grider, Who Dares Win It, or One, Carillon, I'm not sure what that means. You have Golf Combat School and such, and of course you have a bit of Norwegian history here. GRL Turbo Tape, which is made by Geir Rune Ladehaug back in the day, 1985. So I'm not sure if it's Turbo Tape 1 or 2, but that doesn't matter. I would like to try and play a little bit of Wizard of War. I do have all of this on like a SD card somewhere, but yeah, it's fun to see if we can load it. We also have Astro Chase, I really love that one. Yeah, so let's insert the tape and see if we can see the Commodore format on the GRL Turbo Tape. And once we load the games, it should be Turbo Tape, and let's see what that looks like. So you saw me do the face, and let's go in here and see in the code. We have changed A6 and 7, which are input only. We can't use those. And we will place them at D9 and D10. However, 8 and 9 is already on 9 and 10, so they will be moved further up. These guys are going to be moved a bit further up here. And these two will be moved over there. So that's it. That's all we're going to do. Something like that. All right. What we do now, we just hit this button, which is called Update PCB with changes made to the schematic. So let's see what happened. Since we have pressed that button, we now have some rat's nest here. So that's telling us that something can be changed. So we can have them dangled like this. It's much easier to see. Yeah, so we will start by removing. Press U, delete, press U, delete, press U. This will be really much easier now. Like the first one is okay. Just drag it up, and then you can start from the other side. Like this, and then go up here. See, fewer VS, which is good. So I'm just going to draw a help line from here. Let's have a look what this looks like. Yeah, so this will give us a little bit of an indent here. We're putting this into the machine. It goes in, but it... Yeah, so I think we're good. Okay, so I think we're good if we can just cut the board exactly where the connector stops. But that's not a big problem. I can fix that. We can also measure if you like. Okay, or Alt 3, and that looks already better. It's not very symmetric, but the connector is symmetric, so that means I haven't put this one in the middle for some reason. This must be an earlier version, like 0.2. Yeah, there you see. So you're probably looking for a header. That's good, or else it would. Let's try run. Oh, this will be cool. Let's try port 2. See if that works. Oh yeah. Oh. Okay.